Ah, yeah, there we go.
Now, this is for science class and higher level math classes. That's what this is for. I'm going to work the second problem over there. And what happens in the science classes is you're going to have these logs, and your science teacher is going to have one log written on the board. Like this, natural log. And I know in science they use little letters other than X's and Y's. They use a lot of little bits and pieces. But they're going to have something like that. And then what your science teacher is going to do is they're going to write this. Okay, where these two parts were multiplied together, they did rule 6 from right to left. And then where this division is, they did rule 7 right there. Okay? And what it does, it makes it easier to work with just the little parts instead of having all of this big fraction. You know, if we just totally eliminated having a fraction there, okay? And maybe your science teachers don't like fractions. I didn't really say that where it's recorded. And the only other thing that I'm going to show you is you can bring that 2 to the front. Now, in calculus, bringing that 2 to the front is real important, knowing that you can bring a power out to the front, okay? Because it'll make it easier to do the calculus step. But this is called expand. This is expanded. And that's what we're talking about when we talk about expanded. And the problem is, I'm just showing you how to do it. I'm not showing you how to do anything with it. All right? I'm sort of handing you a wrench and showing you how a socket set works, but you don't have anything to work on with it. Okay? It's a tool. Look down at number 4. And I like number 4 because it teaches you something that's important for the future. Notice I'm just working through some of these to help you out. It's got log 100x. Folks, that's log of 100 plus log x. This is one your science teachers would like. The reason they would do that is because if that's an understood 10 there, does everybody realize that equals 2? Do I need to write out the steps to make it equal 2? No. So you get 2. I'm going to write out the step. Because I'm kind, caring man. I put the 10 there, so you get 2 plus log x. And this one drives kids nuts in science classes because they're using base 10 all the time, and your teacher writes log 3000 z. And then all of a sudden, your teacher writes 3 plus log 3 plus log z. And they don't write any steps in between. Okay? They just write that. Well, here you go. That's log 3 times, or plus log 1000. Is that okay? Because 3 times 1000 will be what? 3000 plus log z. Z. And then that is 3. I actually put them in the wrong order to make it look pretty, but that equals what? 3. All right? And that's what they're getting at. Is it's a way to rewrite these. Look down the page, though, at number 12. Let's go ahead and jump into something a little. Let's do. Yeah, we'll do number 12. We may back up and do number 8. Number 12. 12. And like I say, this is one of those things where I'm just showing you how it works, but you haven't used it yet. Now, on Monday, we're going to use this a lot because we're going to condense them on Monday. Okay, number 12. Natural log. Parentheses, natural log, parentheses, e to the ex. Folks, I just got to talk to you about natural log for just a second. Rule number 3. Log base b of b raised to some power equals that power, right? Okay? Well, check this out. Natural log of e to some power is going to equal that power. Because what is understood to be down there with that natural log? An e. So look right here. You got natural log of e raised to a power, don't you? So it's just going to be what? Ex. That part right there, there's your rule. Natural log e to a power. And it's e times x. Okay? So you use rule 3 right here. Rule 3. Put me a little e there to help you. And I'll just tell you, when you see natural logs, don't fear natural logs. Natural logs are a transcendental function created in calculus. And it's the one everyone wants to use because it's the easiest. Okay? It's one of those pretty things. It's natural log. Okay? It's a log with no preservatives or additives. Oh, come on, I didn't get a smile. It is a log with no preservatives or additives. It is a natural log. All right. Now, on this one, it's not natural log with e raised to the x. That would be different, right? This is what? E times x. So, that's going to be natural log of e plus natural log of x. Ooh, and you better know what that equals. That equals how much? Natural log of e just equals 1. Because the power is understood to be 1, just equals 1. Yeah, 1 plus natural log of x. And this, I think you can already tell, this would be a lot easier to work with than something that looks like that. Okay? So it helps us rewrite formulas. It helps us make the formulas look better. Okay? Now, look at anything down, any even down to 18. And if you'll pick any even down, don't pick 18 because it's just like what I just did. It's just more steps, right? But pick an even down, anywhere down to 18. Someone pick 16. Okay, yeah, 16 is not going to be fun. But I'm going to tell you something. 16, do you see our trinomial there? When you see a trinomial, folks, I'm going to suggest you try to factor it. 16's, yeah, that's a good one. That's a tricky one. Here we go, 16. Natural log, oh, I got to tell them that too. Natural log, 7x squared minus 42x plus 63. First thing I know is what will factor out of all three of those? 7. So I'm going to do natural log 7 times x squared minus 7 times 6x plus 9. Fair enough. And that factors. Anytime you see a trinomial, you probably need to factor it. All right. Most likely you're going to have to factor it. And that's going to be what? X minus 3. X minus 3. I think everybody here already knows. I'm going to make that natural log of 7 plus, I'm going to make that natural log of x minus 3, and I'm going to put a 2 up there, right? But somebody says, no, Mr. Evans, I brought the 2 and put it where? Yeah, because think about it. If you actually write it out like this, you got 2 of them, don't you? Mm-hmm. Yeah, so that thing about bringing the power to the front really works. You could have done it either way.
So you'd accept both ways?
Mm-hmm. Yeah. And who asked that question? Because that's good. Yeah. Basically, The good news is I'm going to have you do this, and on Monday or Tuesday, we're going to end up getting this to work out to be x equals something. And the good news about that is it makes it easier for me to grade. But yeah, if you stopped here, you'd be able to get through a science class. All right? Yeah, your science teacher, if you can get to here or here, your science teacher's going to be happy. And please, when you're in college, when your professor writes this down, and then he writes this down or this, please don't ask him to fill it in. Just put a little question mark there and go back and find the rules. All right? All right. Now, let's look at the next little section about all this. That's called expanding. I'm also going to teach you something about standardized tests. If you're taking a standardized test and they give you a log like this, you're probably going to need to expand it on a standardized test. If they give you a log like that that is already expanded, guess what you're probably going to need to do? Condense it. I mean, that's not true in science, that's not true in math classes, but on standardized tests, they're testing to see if you know how to do what? Expand or condense. Somebody says, well, how do I know when I'm going to use one of these? Well, it'll look clearer as you go through it, but for standardized tests, if they write it expanded, you probably need to condense it. All right, let's try one. Let's try, I may make up one or two for this first. Let me show you the trick or the key to this. Let me show you the part that students miss. Okay, it's just an example for condensing. Two log x plus log, hey, how you doing? Did you check in? Okay, do I need to get the temperature here, young man? There you go. You're good. All right. And here's where you got to be real careful before you try to combine them. One little simple thought here. You cannot combine those with Rule 6 if there's a number in front. You can't combine them if there's a coefficient in front. So first thing you do, then make it what? Log x squared y. And I'll put that in parentheses like that. Is that all right? Now, sure, you can skip this middle step, and your science teachers do, but don't try to combine them with a number in front. You can't have a coefficient out there when you combine them. Everybody's hearing that? That's what gets you in trouble. Okay, look at 26. 26. Let's go ahead and pick on a hard one. 26. Okay, 2 log base 5 of the square root of x. I'm going to go ahead and write that as x raised to the what? 1/2. Is that all right? And that 2, there's supposed to be a set of parentheses there. I'm trying to not work the wrong or work a different problem and I call that y. Okay. Now, if you want, since that 2 has parentheses, you could go ahead and combine these two. All right? Is that all right? Because they're inside of what? Parentheses. So we could. Or you can do what? Distribute out the 2 and then bring it in and make it a what? Power. Is everyone okay with that? Students probably like distributing out the 2 first. I mean, y'all think distributive property, y'all probably distribute out the 2 first. But since that is in parentheses, you can combine them first. But if you're not sure, let's distribute out the 2. Now, you can't combine them until you do what with that 2? Bring it in and make it a exponent. Does everybody agree that if you have log, if you have x to the 1/2 and then you square it, you're just going to get what? X. and then you're going to get minus log base 5 of y squared. Now combine them, log base 5, x over y squared. Kind of happy with that one? Is that doable? And like I say, this is, I don't know which one students find easier, either expanding or condensing. I don't know if students find one easier than the other. Look at 34. Before I say look at 34, any questions about what's on the board now? No, I'm not going to ask those leading questions and all that. If you've got a question, you need to be raising your hand. That's my leading question. The train is leaving the station. Anna Karenina, we don't want to have what happened to her happen to you when the train's leaving the station. Anybody know what happened to poor Miss Anna Karenina? She didn't leave the station. She got hit by the train. She threw herself in front of the train. Yeah. She had been fooling around on her husband with a general, and she was like one of these really, wealthy ladies from a wealthy family who had married a wealthy family to keep their wealth and all that, and her husband and her, it's kind of was arranged by all the families, but she's trying to be faithful to him, but she meets this guy that's like a general in the military, and they start having a big time fling, and then she starts feeling guilty about it. So she goes to the general and she says, I hate to do this, but I've got to quit seeing you, and I must be faithful to my husband. I'm going to recommit myself to my husband, and we must quit seeing each other. And the general looks at her and he goes, well, that's fine, Anna. That's not a problem at all. I mean, I travel the world in the military, and I always find women wherever I go, and you were just one of those women. It's not a problem for me. That didn't make her feel very good, did it? So then she goes to her husband. She tells her husband, oh, I've been unfaithful, and I want to rededicate myself to our marriage and make it a good thing. And her husband looks at her and goes, hey, Anna, I don't care what you do. I've got my 3 or 4 little friends on the side that I hang out with, and as long as you don't bring a bad name to the family by letting people know about your little affairs, I could really care less. So Anna becomes very distraught. She throws herself under the train. And that's probably not quite how the story goes, but that's pretty close. And the problem with this book is, sir? Oh yeah, it's called Anna Karenina. It's about Anna Karenina. Here's the problem with the book. The book's like this thick. It's like 2,000 pages. You have to read 100 pages before she's a character in the book, even though the book's named after her. And then after she throws herself under the train, there's still another 200 pages after that, and she's gone. Yeah, but I just summarized how it ends right there. How it should end, but there's another 200 pages after that. Okay, back to math world. Look at number 32. 32. Now, it says log of 30. I'll need the math break. Log of 30 minus log of 2 minus log of 5.
Isn't there understood?
There's an understood 10 right there. Yes, ma'am. Every one of those has an understood 10. Okay. Before I do that, though, I'm going to go ahead and make that log of 30 over 2 times 5. And I'm going to go ahead and put that step in there, 2 times 5. And why did I put the 2 and the 5 in the denominator? Because we got what? Subtract, right, yeah, so we're using rule 7, see? Now, somebody says, well, Mr. Evans, that just reduces the log of 3. Yeah, it sure does. And that's one reason we like for you to be able to do this, because it helps you to get things a little less complicated. We don't condense them much in the classes that I've taught in math. We usually are always expanding them, but condensing them, there's a reason for it. All right, now, I'll let you pick out one even one from 20 through 38. 29? Okay, I'll do 29. I'll do 29. Sure will. I usually, I can't believe we'll do that, but I will. I'll do that. You listen to me tell you about poor Anna. 29. Now, what would you do first if you were working 29? Would you distribute that 3 out first?
Oh, yeah, probably.
Okay, let's do that. 3, natural log. And I bet you would change that to z to the 2/3, wouldn't you? Would you change that to z to the 2/3?
Z.
Yeah, z.
Oh,
Yeah. That's what the English call that fellow, z. I guess they had Led Zeppelin.
so you
Lead.
can distribute the 3 to the alien H1?
Ah, very good, young lady. You're absolutely right. The 3 right there, too. Now, what are you going to do? You're going to bring the 3 back in and make it a power right there, right?
Mm-hmm.
I think that's just going to be natural log of z. I'm going to make it natural log. And here I need to put that in parentheses. Or I could just put a what? A 3 above each one. Either way you want to do it. I think it would look better with just a 3 above each one. What do y'all think?
No, it's okay.
You like that? Or, yeah. But anyway, when you finish, you're going to have this. X cubed, Y. Yeah, I like it better with each one of them cubed like that.
Mr. Evans, how do you get from the 3?
From here to here?
Yeah.
That's a good question. I won't even play. LNZ, 2/3 raised to the 3rd. What do you do when you raise power by power? You
Multiply.
and 2/3 times 3 is
6 over 6 over 3. 2.
it's 2. That's the reason I. Okay.
Wait.
Man, you should have turned off the recorder for that. 2/3 times 3 should be a 2 right there.
It's okay.
Yeah. Yeah, I wish you'd just turned off the recorder for that one, man. You're sitting right beside it. Click, make that
I
one
was
look
just letting
good.
him do it.
All right. I'm trying. Okay, now, I'm going to go ahead and look down here at some of the, these are a little more difficult, but let's see what we can do. I want to look at number 44. These are more, a little more challenging, but they're not that bad. And it's going to show you some of the little neat ways these things will simplify. Let's do 44.
So what would that be considered? Just regular logarithm of like expanding?
Okay, see how it's already got a log minus a log?
Yeah.
I'm probably going to condense it.
To that?
I think I'm going to condense it. I do. Yeah, because it's already got what? Log y squared minus, is it okay if I go ahead and write that as log x cubed? Everybody see what I'm getting at there? Because I can't combine them unless I bring that 3 back up as a power. I'm going to combine them. I'm going to get log y squared over x cubed. And then I'm going to have a moment for a student to tell me some really good news. What does that reduce to?
Y squared over x cubed.
That's right. That is that rule that Mr. Evans, rule number 5. The one Mr. Evans told you he always forgets to put down in the rules. Euler brought that rule off the mountain. If you have a base raised to log of the same base, it's going to reduce to whatever that is right there. teach you today. There you go.
Wait, can you explain this second step one more time?
Here to here, or here,
From the
Here,
top,
here.
yeah, right there.
so you got the minus right there, right? So I made it 1 log, first part divided by that part. Okay. Then once I did that, I had 10 raised to the log base 10. That's rule 5.
Oh, I didn't pay attention to that ten
So
right
is-
there, that's all.
So from the top to the second step, is that a rule?
Okay, that was rule 7.
Okay.
Yeah, it's good, good. Okay, here, yeah, that was rule 7. And that was rule 5. And that's one of those ones we forget. Remember when I was doing the rules and I was hesitating about a rule? If you have b raised to log base b of u, that's how they write it in some books, that just equals the u. I think I put an m up there, or an n, but. Okay, well, let's see how many more mistakes I can make.